Welcome, this is an FP1 video on parabolas. Now this first video goes over the Cartesian form of a parabola. I'm also going to be mentioning what the focus, the locus. Unfortunately I'm not going to be doing the hocus pocus, although that is a bit, I might do a bit of a dance somewhere along. Anyway, so we're looking at the locus, the focus and the directrix. And obviously explaining what a parabola actually is. Okay, so firstly what I'm going to do is draw a set of axes, okay? So these are the standard axes that you might see. So we'll call this y-axis and x-axis, okay? And we'll draw a standard parabola. And when I say parabola, it's actually, I'll just draw it, okay? So it looks like this. It's symmetrical on either side of the x-axis, okay? So it goes through 0, 0. Touches 0, 0 and sort of comes back out, okay, on this side. So what do we actually mean by this locus, focus and a directrix? Well, directrix, the two ones that we're going to compare are the focus and the directrix. Now there's no other way of putting this. They are both, basically, this is because this curve is on the is obviously on the right hand side of the y-axis, and we're looking at the y-axis in this case. The focus and the directrix are on equal an equal distance from the y-axis, or the origin of the origin. Okay, so right. Okay, so therefore the directrix is just a straight line. Okay. So it's just straight, well it should be straight, it's just a directrix, it's just a straight line, okay? And the focus is just the same magnitude but on the other side, okay? So we'll call this the focus. And obviously the coordinates would be, I'm just going to call this coordinate x coordinate A, and it's obviously got, it's not got any height, so it's got a y coordinate of 0 because it's on the x-axis. And because it's the directrix is the same magnitude but on the other side, this is going to have an x coordinate of -a, but it's still going to have a y coordinate of 0. Sorry, so it's going to just be x equals -a because it's a straight line up, okay? But the focus is just a point. So now I'm going to actually explain what this parabola is, okay? A parabola is just I'll try to do this without the sheet. A parabola is just it's a locus of points. So basically what we mean by that is any point, you could pick any point on this parabola, or just call it curve C, okay, and the distance to the focus and the distance to the directrix would be exactly the same. So I'm just going to pick this point here, and we'll call it point P, okay? So going from the focus to point P, okay, is the same as going from the point P to the directrix. Now it doesn't look the same length, but that's only because I've not drawn it as that, okay? Now what I'm going to call this point where it hits the directrix, I'm going to call that point D, okay? So therefore what we can say is D to P, okay, the distance D to P is equal to the distance F to P, okay? Because now that you could pick this point P to be any point on the line. I just happen to pick it up here. It could be over here, it could be the origin. Doesn't really matter because they will be the same length. Okay. Now, what we actually want to do is generally what you would ask to do is find the directrix and the equation of the curve. Okay. Now, as I said, they're the same distance away from each other. Sorry, one sec. Yeah. Now, they wouldn't just give you nothing and just say, here's a curve, and draw that curve without any information. They would give you something that would enable you to work out the focus and directrix. This A, by the way, is just a value, it's just a constant. I could have put C there, okay, but you might have thought that was the equation of the curve, so that's why I've put A. What we're going to do here is come up with a standard equation for this kind of curve, okay, and then any equation you will get that will end up looking like this, something in the form. It will become more obvious when we come up with the standard equation for this curve, and anything that's sort of like that, which obviously you will get what I mean by that, you can just skip out all this rubbish and that we're going to do to calculate it and compare it, okay? And then go back through it and redraw it. So hopefully that makes some kind of sense, but it will become more apparent as we do it, okay? So what we want to do is find the equation of this curve. Now, obviously, it's not a y, take y1 equals mx, take x1, mx, take, yeah. You can't do that because it's not a straight line, obviously, it's a curve. And, you know, it'd take a very long time to use trial and error to try and come up with some equation. So there's obviously some easier method of doing this. Now, the only thing that we're told is that the distance, d to p, is the same as the distance from the focus to P. Now that's just, we're not told that, it's just something you should know. But obviously you've only just been told that, so that's kind of why I say it. Okay, so we know the two distances are the same. Now what I'm going to do is square both sides, okay? So dp squared, d to p, the length d to p all squared, okay? Now it's not just going to be a length of 5 or something, because obviously, you know, we won't be doing this otherwise. Okay, so what can we actually make from this? Well, let's look at the distances that we know. Okay, and I'll explain why I've squared it. Now I said the distance on either side is the same from the focus to the y-axis, from the directrix to the y-axis. Okay, they've both got a distance of x. The x distance on both sides is a. Okay, so from the focus to the y line, that's a distance of a. Okay. And from the y line to the directrix, we've also got a distance a. Now this is negative a, and granted going it this way, this is positive a. But they've both got a magnitude of the difference of a. So basically, the difference in the x coordinates is a, okay? Hopefully that makes sense, right? So what else do we know? Well, we know this p, this point on the curve here, is going to have an x coordinate. We don't know what that is. We also know it's going to have a y coordinate. Again, don't know what that is. So the reason why we've squared it is because this looks like the hypotenuse. I know it's very hard to point out here, but what we're doing here is that's a right angle triangle, okay? So you can make a right angle triangle out of that. That's all we can really do with it, okay? And when we squared it, what you would normally do, say, what I'm trying to highlight here, so if you can imagine this P, F, this we'll call this point X, okay? Because obviously it's got an X coordinate the same as P. Okay, this is sort of a right angle triangle. So if I draw something like this, I can actually draw. Okay, so if we draw something like this, okay, so this point P, we'll call it at the top. This point over here, we'll call it the focus. Okay, and this is just point X because it's the X coordinate of P, the Y coordinate of 0. Okay, so we know the P has the coordinates X, Y, and then obviously the point where, so there has X to be 0. Okay. Right, so where can we go from that? Well, say I'm going to call, so going back to Pythagoras' theorem, when you used that, you said, okay, well this was, that was B, that was A, and this was C. So therefore you said C squared is equal to A squared plus B squared, yeah? And then you just said, okay, well C is equal to the square root of A squared plus B squared. We're going to be doing a similar thing to here, but we're not going to be square rooting it, because what we're going to end up having, you'll see that's a bit of a tricky point, we'll end up having to square root x, and we don't know what x is, and we'll just get into a muddle. So what we do is we can leave it, there's nothing that he says, you can't leave it in that form, so that's what we're going to do. Okay? So obviously, this dp, this fp squared is going to end up being something squared plus something else squared. Okay, so what do we mean? Well, let's go back to looking at this. This triangle is sort of a bigger version of this. Okay, so we know this point here, which is we said was the focus, which was the bottom left point of this triangle, had coordinates a 0. Okay, and then this other point here, which is this point, has x 0. So the difference in the x coordinates is x take alpha, or x take a, okay? And obviously there's no difference in the y coordinates because they're both line the x-axis. Okay, so the difference is x take a. And now the increase in y coordinates from x0 to xy, well, it's increased by y, okay? So therefore, if we relate it to this diagram we had before, this c squared is equal to x take a squared plus y squared. So let's just sub that in for fp squared, okay? That's f to p squared, okay? So it's just x take a squared plus y squared. okay? And that is equal to fp squared, or I called it c, it's the same thing, okay? And then this, how we work out d to p squared? Well, it's a lot simpler, okay? We know the distance here from p to y is actually the x, it's just x, it's just an x amount of x coordinates, which doesn't make sense. This a here was just the distance to the focus, okay? It wasn't the distance to the x, to point p. Okay, so we're going from d to p. So to get from d to the y-axis, we said that is a amount of x coordinates, sorry, and then it's plus x amount of x coordinates, okay? Because we're getting from d, getting to the y-axis, and then we're going from the y-axis to p, okay? Hopefully that makes sense. So basically what we're saying there is we're adding a amount of x coordinates plus x amount of x coordinates, okay? So it's a plus x all squared. I do apologise, I've used x twice there. Okay, so what we're going to do now is just expand this out and square it. Now you could do double brackets if you want to. So it's a plus x, brackets, a plus x, equals x take a, brackets, x take a, plus y squared. Now there's no point me just wasting your time and showing you how to expand that, because you're smart enough people to work out how to expand that, I assume. Okay, so what we're going to do is just simply well, actually, I don't know. Should I make a mess? What you should get, anyway, if you rearrange this, you should get y squared is equal to 4ax, which is the standard equation of a curve, like this. Now, what I'm going to do is I'm just rub this out so we can just do a little demonstration where we apply this to a question that you actually might be asked in the exam. Okay, as I said, I'm only going to do one question here. If there's any more, what I'm going to do actually is I'm going to do a question which relates you to using this, this idea, and then it might not always be like this. This point here, the bottom of the curve, might be on the bottom of the x-axis, okay? And it's basically flipping it around, but essentially it just flips this equation, which I'll explain in a bit. But what I'm going to do, just give you a second to copy that down, because all I'm going to do is rub in this little bottom bit off the board there, and I might be rubbing the top bit off if I need some more space lit on. I do apologise, but I'm just going to be rubbing that little bottom triangle off there, so just give me a second to copy that down. So I've just written y equals 12 x squared there. Now there's one thing I just wanted to point out before I actually start going through this. The reason why we know why it looks like this and it doesn't go on the left hand side of the y-axis is because it's y squared. That means, well, y is always going to be positive, because if it's y squared, then anything squared is obviously going to turn out positive. So that's why it always looks like it always is on the right hand side of the y-axis, so it looks symmetrical about the x-axis. Now if that was x squared equals 12y, then that'd be a different story. Then y could be negative, but x couldn't be, so it'd be sort of that sort of shape. Okay, so that's how you dictate whether it looks like sort of a horizontal curve or a vertical curve. Okay, so that's just a little bit of background. So anyway, what we have to do is this obviously looks a bit like this. Now, you could tell straight away that a is 3, but what you need to do is follow this process. Y squared equals y squared, so 12x equals 4ax, so therefore 12 equals 4a, so therefore 12a is equal to 12 over 4, which is obviously 3. Okay, so when a is equal to 3, we just redraw this diagram, but instead of writing a everywhere, we just sub in 3. So obviously, when we draw the directrix, it's x equals minus 3, and when we draw the focus, it's 3, 0. So in that case, it asks you, for this question, it asks you to draw the curve. Now the curve would still intercept the y-x-axis at 0 at the origin, because, well, when x is 0, y is 0. It applies for both cases. Okay, so really, it's just a case of applying a is equal to 3 to that equation. Now, anything like that will always look like that. That makes sense. I mean, it sounds like obvious, that really, but hopefully you can see where the alterations might come in. Okay, so obviously that was y squared. We're going to do one that's x squared now. And the one that we're going to do is x squared. What I'm going to do is I'm just going to rub all that off. So as I said, I'll give you a second or two just to copy all that down if you've not done already, which I assume you have done. And I'm going to have another go at this, but instead of drawing it y squared, it's going to be x squared. But I'm just going to draw the curve and then let you go from there and create an equation like this with it, okay? Following this method. So as I said, you might want to copy it down. Right? So when you've done that. So as I said, all I'm going to ask you to do for this is just going to draw the curve and then ask you to have a go at it yourself, coming up with the equation for it. Okay, so it's going to be an equation with x squared. So obviously we're going to look at it like this. So we've got a y-axis and an x-axis, and the curve looks like this. Okay, now it's not y is equal to x squared because, well, I'm just going to compare it to this. Okay, we've got the focus, which is not A0 because it's 0A, okay? And the directrix is going to be, sorry, I do apologise, y is equal to minus A, okay? So what I want you to do is have a go at coming up with the equation for that curve. Now, as I said, I'll draw in a point for you. I'll draw it over here this time, so point P with x coordinate x and y coordinate y, okay? And this would be the focus, sorry. So just draw that and hopefully you should get the rest of it from there. So we're just on this point D. So I'll just let you have a go at that if you want to have a go at that. As I said, I'll be going through that, so don't worry if it doesn't jump out at you. Just try to apply the method we did before to come up with an equation for that curve. Now it should be something fairly similar, otherwise I wouldn't have asked you to do it on your own, okay? Right, okay, so hopefully you've had a go at that. So what did we actually do? Well, it was quite a tricky one actually. What we have to do is we draw this triangle in, okay? Instead of looking at it from the triangle looking something like this, okay, where we had point P, the focus, and then this x coordinate, what we're going to look at it as, we're going to look at that side on, okay? So really it looks something like that, where you have it, okay? So it's just a right angle triangle on its side, okay? So it looks something like that. So this triangle represents this one over here, okay? So what we've got is point P up here with x, y, okay? What we've got over here on this point is the focus, which is 0A, okay? Right, that's the focus. And we still apply the same method, so the focus to P, FP, all squared, is equal to dP, all squared, okay? So you apply the exact same method to that, okay? So what we want is this here, and we want that, okay? And we square these two to get that squared, okay? So what it is dP, we're going to be working out FP squared first. So obviously the distance between the y-axis and P, well, it's 0, and x is x. So it's x squared plus, well, obviously what we've got here is the height from the x-axis to P is y, okay, because we've got an increase from, we'll call this point x0, okay, to xy, it's an increase in y, okay, but all we want is this little point here. Now if we look across, that's got a y coordinate a, okay, so therefore at this point this is xa, right? So between xa and xy we have a distance in the y coordinates of y take a, okay, so that's y take a all squared, okay. dP, well obviously at here our y coordinate is negative a, okay, and up here our y coordinate is y at P. So we want to get from D to P, okay? So what we've got here is the distance between the y the y coordinate of P and the x-axis is y, and then the distance in the y coordinate from x to the directrix is negative a. Okay, so it's y plus negative a, or in other words, y take a all squared. Oh, sorry, no. It's not negative a, sorry, I do apologise, because we're not taking away, I do apologise, to just add the positive sign, because we're adding y plus, it doesn't matter if this is negative, that the distance here is still a, it's negative a, but there's still a distance, the modulus of it is a, okay, so it's y plus a all squared. Now, you expand that out like we did in the other question, so therefore you get x squared is equal to 4ay, okay, so which is just sort of the opposite of what we said before, where our other curve, when this looks like that, okay, the curve for this was y squared equals 4ax, and as you can clearly see, them two are related, okay. Now just before, when we had y equals 12x squared, you can have a go at that by saying, okay, well x squared is 12y. It's just the same sort of principle, really, as before, okay. So that's really the end of this first little bit to the parabolas. This was the Cartesian equation. Sorry, I keep saying because I'm trying to think of the title topic, but it's just going off my mind. Okay, so thanks for watching. Hopefully it's been of some help, and we'll see you in the next video.